Hello, everyone. So today we're going to be going a little bit more deeply into the things we've been talking about. So hope you all are doing well. We're going to be checking out today. We're going to be checking out chapter 2 in our stats book. And this one's basically just kind of going a little bit further from the vocab that we learned last time and sort of applying it. So one of the main things we talked about that we'll be doing this term is right up here at the top, and this is what we'll be looking at today, is the idea of descriptive statistics. So basically, there's two types of statistics. One being the one we're doing, descriptive, which I'll give a deeper definition in a moment, and the other being inferential. So descriptive statistics are the ones that help us get large bodies of information and making it make the most sense possible. So if we're talking about the idea of stats being a way to tell the best story possible, we want to be able to organize our information in a way that makes it easier to tell our story. Whereas the inferential statistics is what we might be doing in a more advanced stats class, where we actually start using these tables to make predictions. So for now, we'll just be taking a look at descriptive statistics, specifically looking at how to organize the data in things called frequency tables. So essentially what a table is you take a big body of information, and we'll look at an example in a second, and organize it in a table, and just tables that you normally see with headings and rows and columns that make the most sense, and organize the data in a way that it makes it easy to read and understand. So frequency, there's two types, two words we'll be taking a look at today. One is frequency. This one's usually going to have to do with numbers. So this is usually a table made up of just counting how many people said something. So if you had a survey of how many people liked a movie that just came out, you would count people that said yes, and the people that said no, and the numbers you had would be frequencies. Whereas the other option is proportion or percentage, where it's the same idea, you get the frequencies, but you make it in a way that puts it in a percentage of the whole. So if in a case of you surveyed 20 people asking if they liked a movie or not, 10 said no and 10 said yes, you would then say 50% thought it was good and 50% thought it was bad. So that's how you, in basic terms, how you go frequency to percentages. So take a just basic definition. I'm going to start off in the first part. We'll look at definitions, and each one of these will look in more detail as we go throughout this lesson. So a few ways of making sense. Like I just said, a frequency distribution is made up of numbers or occurrences. So in our survey of, let's say 20 people asking if they like the movie or not, 10 people said yes, 10 people said no. This number here would be the frequency. Percentage distribution would just be that same idea, but just turned into a percentage. So it'd be 50% and 50%. So half and half. Okay, so those are the two main things we're looking at. And then the second two are kind of subcategories of that. This one being rates. So it's one of those things, we'll go into an example later, but basically if you've ever heard on the news something like poverty rate or unemployment rate, all they're basically saying there, it's a specific type of one of these frequencies, and all you're going to do is put the number on top. And in the case of number of people in poverty on top, and below that would be the total population. So the top one, if you recall from math, is the numerator. And the bottom one was the denominator. So the numerator and denominator, so the number of people in poverty on top of the population. So say in our example of, say it was a city of 100 people, that would be the population, and 50 people were in poverty, so then you could say it's a 50% poverty rate, because 50 divided by 100 is 50%, which would be a very high rate. But the idea being, it's a very simple equation. Whatever number you're looking at, the number of people that have that characteristic, whether it's unemployment, poverty, on top of the total population that you're looking at. And we'll go into a deeper example later on. And the final thing is cumulative distributions. So basically it's the same idea as the frequency tables, only it gives you like a running total. So each category you go down, it adds up all the categories from before. So I like to just call this the running total occurrences, and it always adds up to 100%. So we'll do an example of this. Just always pay attention in the homework questions. If you see the word cumulative, they're asking for the running total. And we'll give some examples in just a bit. So these are the basic ideas that we're looking at. So let's first take a look at what a frequency distribution is all about. So this table is actually from our book, and it's a table of 40 people. So if you look up top, it says 40 respondents up on top. And this is just raw data. So if you were to take a look at this, there's not much you could do with that really, in the sense that it's really confusing. You might gather by looking at the categories. There's the gender of respondents, so it's either male or female. It's the degree that somebody has, bachelor's degree, high school, graduate, less than high school, a number of children that they have, and then find their age. So there's these 4 characteristics that basically, this would be a question that if we gave it out to everybody in the class, and they all answered this, it would look something like this. Now, raw data, so this is what a frequency distribution comes in handy, is to take this very large amount of information and make it make more sense. So if you have your book, you could open this up. It might be helpful to have this open as you do this example. And also, I'll have it in the notes that are on Canvas. So it'll just be our Soch notes that are on there. And if you look this up, this table will be in there. So you can access it either way. I recommend having this out so that you can take a look at it as we go through the problems. So basically then, what you're asking yourself when you're doing a frequency distribution is you want to take something like this and want to minimize it and make it more digestible. So I'll show you what I mean. Scroll down here in a little bit. So basically, these charts down here are examples of making that chart more digestible, depending on what you're interested in. So I'll show you what I mean. So you can make sense of too much information, and these 2 points here can be organized based on whatever makes the most sense to you. So you can see that this chart number 1 is organized based on education level, and chart number 2 is based on number of children. So for instance, what I'll do here, we'll go through an example and I'll show you how we got this total here. So for instance, in less than high school, it basically means you look for this category up on top. Or going back a step, if someone were to ask you then from that chart, how would you make sense of the education level, or what is the average education level of the people in that survey? You can make a chart that looks like this. So for instance, we'll go up and look for less than high school. We'll go up here, take a look. So less than high school, I see 1, 2, 3, 4. So there's 4 total there. So if I go back down to your chart, tallies 1, 2, 3, 4. Therefore, the frequency is simply the number of people you counted. So there's your 4. And the percentage here is 10. And the reason it's 10 is because we know, well, I'll go show you. We know if you could either count it up, but you could also see up here, this is out of 40 respondents. So we know the total is 40. So simply then you would figure out that 4 people out of 40, which is the total, equals 10%. So that's where that percentage comes from. So you see here the cumulative percentage. We'll take a look at this as we move. So right now, the cumulative percentage, like I said, is the running total. So it's always whatever category you're at plus everything that came before it. In this sense, there's nothing before it, so it's simply 10%. So let's do this again. Let's do this for high school then. Let's go up and count the number of high school. And if you're to go down and count all these, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 total. So you go back here, I counted 24 tallies, and your frequency is 24, because that's the number of times it happened. Same thing as before, it's 60%. So that would simply be done by, if you have your calculator, you could use your phone or Google calculator. 24 divided by 40 equals 60%. So that goes there. So here's where the cumulative percentage gets interesting. So like I said, this category is everything that came before it. So it's 60% in this category, plus the 10% in the category before. So your grand total is 70. So the cumulative percentage is 70. Okay, 70%. Same thing with bachelor. If you went up, you would count 6 in your frequency. Percentage is 15. And again, cumulative percentage is taking this category plus everything that came before it. So in this case, is 15 plus 60 plus 10 is 85% percentage. And finally, the same thing, go to graduate level, go back, let's go back and count that one out. So you're just looking for the people that said graduate here. 1, 2, 3, 4, 5, and one down here, 6. So you go ahead and do 6 tallies, 6 frequency, and the percentage will be 15%, because it's the same as before, 15%. And if you'll notice here, when I go back to do cumulative percentage, let's actually clear this up a little bit. When I go back to do cumulative percentage, I'm going to take the 15 plus 15 plus 60 plus 10, and it's an equal 100%. And something to note, the bottom level on the cumulative percentage should always equal 100%. And the reason this is because cumulative is asking you what percentage of the total. So once you get to the bottom category, it's always going to be 100%. So we have this one filled out then. So 100%, the cumulative percentage is filled out. We have the regular percentage filled out and the frequency. So let's take a look at this a slightly different way, the second option. So if the question were asking you, rather than education level, they're interested in number of children, there's several ways you could do this. As you see, I broke this down into 3 categories to make it easier, because the idea is, you go back up here, the best idea is to make sense of too much information. So for this chart, instead of breaking it down, if we go up above and look at the number of children, there's a whole bunch of answers up here. You know, there's 1, 2, 0, 4, 6, it goes all the way up to 8. So there's lots of numbers. If I were to do a category for each one of these, it'd be rather messy. It wouldn't be easy to understand. So part of the ways to do this then is to do no children. So you go back and do it that way. Less than 2 children and more than 3 children. So the instance then, if we go back and we count them, I actually have it filled out for us already. So if you're to go up to the top and count no children, you get 13. Less than 2, 15. And more than 3, 12. It's the same idea. It should add up to 40. And same thing with the percentages, should add up to about 100%. So always when you're thinking about these things, the frequency should always add up to the total. So in this case, it was 40. The percentages should always add up to 100%. So those are 2 versions of looking at that. So based on what we know about cumulative percentage and frequencies, there's also a way of working backward. And the reason I show this to you is because one of the 2 of the homework problems are going to have something that looks like this. So what if I were to give you something that looked like this? It had some of the pieces missing. So as you can see here, you see we have the bottom category completely filled out. So there's several ways to go about doing this. I'll show you one. So for instance, if I wanted to make sure this was completely filled out, we'll see here the cumulative frequency is 40 here, right? And the frequency here is 6. And all these different percentages are here. So we see, for instance, one way to notice this is these 2 percentages are the same. So we can imagine these frequencies are the same. So we fill this one out. Bachelor is 6. We imagine these are going to be the same. So cumulative frequency, if you recall, is this category plus all the ones before. So one way you could do that again, you fill this out this way, is to take the cumulative frequency and subtract the frequency in that category. So for instance, 40 minus 6 equals 34. So we know then the cumulative frequency here is 34, because we know that there's 6 added to it. We could also have our 6 here, because we know that's the 6. And same idea. You could do this category, then 34 minus 6 is 28. So we know cumulative frequency here is 28. You start looking at some of these things then. So we start figuring then, if this is 40, 34, and 28, we could start taking a look here. So we're still missing 2 categories. We're missing a really big category, and we're missing the cumulative frequency category. So we know this one would also be 4, because we know the cumulative frequency here is going to be 4 because there's nothing above it. And so we're just missing that last category here. So the question you might ask yourself is, how does this 4 become a 28? So again, you could subtract, the idea would be 28 minus what equals 4. You can see here 28 minus what equals 4, and you'd see that that could be the number 24 in this case. So I ended up filling it all out. I now know the frequency is 4, 24, 6, and 6. And for here, cumulative frequency 4, 28, 34, and 40. So basically, it's the same idea as before. Any of these working backward problems are always going to have all the information that you need. You just need to start thinking strategically on how you're going to fill it out, whether it's looking at the percentages, looking at the frequencies, and start filling it out from there. Okay? So this might take some practice, but it's always available. The 2 or 3 problems that we have are going to be able to be figured out with the information given. Okay? Scrolling here. So here's the example of poverty rate that rates I was talking about. So determining rates. So this is a unique frequency. It's very similar to the one we talked about before. We just call it rates because generally it's describing a specific characteristic. So in stats, when you're telling the story, if you're a government official and you want to talk about poverty in the United States, you might describe the rate. So in this case, as with any rate, you take the number of people that have this characteristic over the total population. So in this case, in our example, let's say there's 40, from up here, let's say there's 46,657 people in poverty. You take it over the total US population, which is 315,804,000. And these numbers I just took from right here. So if you divide those two numbers, you get the rate of 0.15. So this number here could be your final answer. It's 0.15. And as a brief review, when we're talking about converting this percentages, whenever you want to turn a decimal into a percent, you multiply it times 100. And basically what that'll do is that moves the decimal place over 2. So you end up with 15%. Times 100. So if you were to enter this in your calculator, 0.15 times 100, you get 15, meaning that there's a 15%. And 15% what? In this case, 15% poverty rate. You do the same thing with unemployment rate. Let's take this one up here. So if you were a politician interested in looking at unemployment, and you wanted to talk about a new policy, you might want to describe unemployment as a rate. So in this case, at any rate, you take the number of people with this characteristic divided by the total population. And in this case, we'll take the number 75 million people are unemployed over the US population of 315,804,000. And again, you would end up with a number 0.242. And if you wanted to turn this to a percentage, you multiply it by 100. And that means you move that decimal place over 2. So you get 24.2%. So as a politician, you could say that the unemployment rate is 24.2%. Perhaps we need to do some enact some new policies. So rates are simple. If someone's asking about a rate, it's simply whatever rate they're looking for: unemployment rate, poverty rate, graduation rates. You take that number over the population. And finally, this is just kind of a review. We'll be looking more at these a little bit later. So basically, like I said, the whole idea of stats is to tell the best story possible. And one of those ways is to be able to turn these things into, turn your numbers into charts. So if you're presenting information, sometimes a chart is easier to read than a table. So these are some pictures from our book, kind of essentially looking at the same numbers, just displaying them in different ways. So this one over here, for instance, is a histogram or a line chart. Or histogram. Whereas over here, this is a bar chart. And the final one is a pie chart. I'm sure you probably run into these at some point in your life, whether academically or just watching the news. And so depending on what you're trying to present, these three, for instance, are all saying the same thing. They're just displaying it in different ways. So perhaps whatever your story is or whatever point you're trying to get across, you might use a histogram or a line chart, a pie chart, or a bar graph to try to show your point. And one final thing to note with this is, in addition to doing them in different formats, you could also pull out numbers. So for instance, right here in the pie chart, this is called exploding. So the idea is exploding is you're pulling a segment out, exploding a segment of the pie chart in order to highlight some information. So if you're presenting this and this 26% here was, we'll go back to our example of the unemployment rate. If you're talking about the unemployment rate as highest it's ever been, you might pull that section out to really emphasize your point. So this is called exploding in the pie chart. And again, any one of these are not necessarily right or wrong, but some of these are better storytellers than others. So for instance, when we're going through stats, we're always trying to find the best way to get our point across, the best way to organize information, and the best way to tell the story that we want to tell.